define the binding energy of a nucleus. What's the binding energy? It's the energy needed to take the nucleus apart into all its parts, right? So if you start off with, say, a helium nucleus, right, this has some mass, right? And then if you take it all apart into 2 protons, 2 neutrons that are isolated, right? That would take a certain amount of work to do that, and that's what the binding energy is. It's a measure of the stability, but it's only 1 mark. By the way, it's also the energy released if you combine those things together somehow in some magical fusion reaction to create this, okay? And then deduce using the data below the binding energy per nucleon of the nucleus of tritium is 2.66 MeV, right? So we use neutral atom masses. IB likes to give us the mass of the nuclei. So notice that the mass of the proton is a bit less than the mass of the neutral atom because the neutral atom would have an electron on it. But let's just go with the masses they're giving us here, right? So you're going to compare, you're going to go mass of this, right? The mass of tritium minus the mass of its parts. And of course, tritium is made out of 1 of these and 2 of these, right? So figure out the mass of that, right? And then you're going to multiply by 931.5. And that will give you the total binding energy, right? But they want the binding energy per nucleon, right? So I think I actually got this wrong because I just left it binding energy, but they want per nucleon, right? How many nucleons does it have? It's got 3. So once you get the total binding energy, divide by 3, and that should be 2.66 MeV.